Good morning, everyone. Okay, let's start our class today. Right, so first we're going to go over the derivative of 1 over x. So everybody knows that when we take a derivative 1 over x, we are going to get a ln of x. Am I right? Or we should have a ln of x, derivative of that equals to 1 over x. Something very important to showing us that we should remember our power rule formula, right? When we do the derivative, x to the nth power or we take a derivative of ln of x. When we take a derivative of ln of x, result will be 1 over x. Derivative of x to the nth power, we're doing give n in front, exponent minus 1. So when we do 1 over x derivative, we have to think about to rewrite this to be x to the -1. Then apply to our formula right here. But today's topic we are gonna do the integration, right? So we're gonna work on integration of fractional functions. So basically we will take an integration of 1 over x dx. And what is the result we're gonna get? Now we look at take integration of 1 over x. So integration of 1 over x, which we're gonna apply for the inverse of that. So we know we should get a ln of x. But now we have issue here. Remember, it's log function. When we have a log function, inside must be positive. In order to keep this true, we have to give absolute value by ourselves, then plus a c. So now we gonna use this to apply some problems to see if we are able to use this idea to solve. So let's say we have one over x squared dx. How are we gonna solve it? Can we apply this formula right here? So the only time we can use a lim is we have to check our denominator. Alright, so let's check our denominator for 1 over x. The denominator I'm talking about is x. The degree is 1. Let's check out our second problem is 1 over x squared, which we have done many times before. Our degree right here is 2. Since it's a degree 2, we can easily rewrite this into x to the negative 2. Then we can finish this by the x negative 2 plus 1 over negative 2 plus 1. Right, we have done this many times. Plus a c. Now this tells us the first thing we have to look at when we're dealing with rational functions is we have to check the degree for the denominator. Now my question is, if I give you a rational function, can you tell me what is the degree is? For the denominator. So we see this is not degree of 1. We have a 3. Most people answer that. So whenever it's not 1, we're not going to think about a lim to solve it. The first thing we think about, okay, let's rewrite this into exponential function form instead of thinking rational function. Alright, so we're going to rewrite this. That's going to be 4, 3x plus 2, go to negative 3 dx. Then we're going to use our substitution shortcut to solve it. Right, so let's review our shortcut. Shortcut is we define our base as u. We get my u prime, which is derivative of the 3x plus 2. Going to be a 3. Now we have to provide a 3 by ourselves, so we're going to make it. Right, so now we're going to do is give 1/3. I'm going to move the 4 in front since it's constant times the 4. Now we have a 3 in front to prepare us to use the u prime method. So after we prepare everything, now we can get our final answer. 4 over 3, 3x plus 2, negative 3 plus 1 over negative 3 plus 1 plus c. Now let's look at the new problem we have. I'm just going to rewrite similar problems which have a different degree. Alright, so let's say I have the same 4 over 3x squared plus 1 dx. Now I want to know what is the degree of my denominator. So we look at this one as a fraction. So the degree we are talking about right here is for the whole denominator. So we're going to consider my denominator right here is a u, a function. So what is the power for this whole denominator right here? It is 1. So we are looking at this one as 3x squared plus 1 to the first degree. So whenever to the first degree, we are thinking this is rational function form to solve. So this means we have to think about a ln to solve it. So let's, x squared is going to be hard, so let's do something a little bit easier. Let's think about we have 4 over 3x plus 1 dx. Now let's back to our formula we discussed. The first formula we provide is 1 over x dx equals to ln of absolute value of x plus c. Can we use the formula right here to apply our new problem? If yes, our answer will be ln of absolute value 3x plus 1. If no, there's something else we have to do. So now we are dealing with a problem which denominator is not x. It's 3x plus 1. So we have to think about this is something we learned before. When the base becomes a u, so we have now is 1 over u. So whenever we have a u, we were doing the u prime. We're going to apply the same idea that we should find u prime to help us to use ln to solve it. So how can we find u prime? We just take a derivative of 3x plus 1. Right, so if I have a u prime provided for us, which we always put in front, I'm going to put in front right here. If this happens, now we can solve it right away. That's going to be ln absolute value of u plus c. Now I basically give you a new formula right here. Whenever we have a denominator u, we get a u prime, we are able to solve it right away by use ln. Now we're going to follow the formula to see how we're going to do the problem. We have 4 over 3x plus 1. I'm going to rewrite first. 3x plus 1 dx. This is my first time doing this problem. So first thing I'm going to do is, okay, I'm going to look at my denominator. Let's say the power is 1. So I know this is going to be a ln problem. Now I know the denominator right here is not x. So I'm going to define my denominator to be u. So u is 3x plus 1. My u prime is a 3. Do I have a 3 in front? I don't. So we have to make it. So we're going to do the same way we did for the power rule before. I'm going to give 1/3. I'm going to move down right here. So we're going to do 1/3. One-third. I'm gonna move out the 4, so that's gonna be 1/3 times 4 is 4 over 3. 3, because that's how we make 1/3 times 3 is 1. 1 over 3x plus 1 dx. Now we can follow our formula. This is u prime. I create, everything will be fine. Now we are done. So 4 over 3 ln of the u is our denominator, is 3x plus 1 plus c. Now let's change the degree of function, but the denominator, the whole denominator, still have a degree of 1. Now let's look at our new problem right here. X squared minus 1. Now the question is, can we use our u prime to solve this problem? If you think we cannot do it, you should tell me why we cannot do it, right? The problem has to be, can we create our u prime? What is our u prime? So I check, it's a degree 1 for the whole denominator. So I have to check my u prime first. So the u prime is u equals to x squared minus 1. My u prime is 2x. That means I have to have a 2x in front, or you think about 2x on the top of the fraction. But can we make it? As we know, we cannot make it. So the u prime method is not working. So how can we solve this problem? As someone mentioned, this is partial fraction problem we have. How do I know this is partial fraction problem we have? Is why we use partial fractions. So let's look at our partial fractions you learned in pre-calculus. Right? Partial fraction meaning is we can rewrite a fraction. I'm going to copy the same fraction right here, x squared minus 1. So I have a fraction right here. So what I'm going to do is we have to do the first factoring. So x squared minus 1 is different squares, x plus 1, x minus 1. This fraction, after factoring, we can rewrite this into two fractions because I have two factors. One is x plus 1. 1 is x minus 1. So this is a linear function. This is a linear function. We can assign a, which is constant number, and a b. So now this is a partial fraction problem you learned from pre-calculus. Now just for a review about partial fractions, I'm going to give you one right here, and then I wanted you to tell me how many fractions we're gonna make. The problem right here, I already factoring for you. So we just have to check the factors. Right? How many factors we have? We have the first one is x plus 1. The second one is x squared plus 3. We will write it right away as two fractions. Do I care about the 3x on the top? I don't. I just follow my factors right here. First one is x plus 1. It's a linear function. Linear function meaning it's a straight line function. It's mx plus b. Right, so whenever we have a linear function, our top will give as a constant number a. The second fraction we have x squared plus 3. Whenever we have a square for the x, and this is give us a linear function on the top. So when I say x squared, I will give b x plus c. I see a lot of you have trouble for partial fractions. That means you already forget how to do partial fractions. I'm thinking about making a special section for doing the partial fractions. This section will also help the student taking Math 206 and 206.5. So I'm gonna let you know the section for special only partial fractions. It's like a lecture, right? So you can go over it. This is just a kind of review, right? If you forget, don't worry. We're gonna do more examples. Okay. There's also a repeating case for partial fractions. I'm just gonna go over a little bit right here. So what I mean by repeatings. Now let's rewrite this problem as 3x x plus 1 squared x squared plus 3 squared. I want you to tell me how many fractions I'm gonna make. So we have power 2 for x plus 1. The way we're dealing with the partial fractions is we have to starting with degree 1. So degree 1 is x plus 1. Then we go on for square, x plus 1 square, plus x squared plus 3. I don't have to give the parentheses, I just did it. Right. So last one will be x squared plus 3 to the second part. Now we have to sign the top. So if it's linear function, we give a constant. So the first fraction, it's very clear, it's a linear, that's going to be a. The second one, let's look at it. The second one is our repeating. Our repeating is x plus 1 is our base. The top, well, still following the slope 1, intercept 1, x plus 1 linear function. So it's still considered to be straight line. It's just repeating for the power of 2. Right, so it doesn't matter. So we follow the base. Base is x plus 1. The top still going to be a constant. For the second one, for the third one, as x squared plus 3, it has x squared. So the base has x squared. Now this is going to be cx plus d. We change the letters. Right, so last one, it's very clear. The base is x squared plus 3. Now that's going to be ex plus f. You may have questions, why are we doing this? The reason we're learning partial fractions is special for the problem we are dealing with. This way, if we set up, we are able to solve the problems. Right, let's look at the first fraction right here. If I'm dealing with rational functions, it's kind of hard. Right, because my u is the whole denominator, and you take a derivative, you're not going to get 3x on the top, similar 3x on top. If I rewrite this into a 2 fractions form, for the first fraction, the u prime will be 1. That's good. The second fraction we have is x squared. So my u prime will be 2x. Can we solve that if we have something like that for taking integration? Let's do that one first, then we're going to go back to the partial fraction again. Right, now I'm showing you why we're doing partial fractions for us to dealing with rational functions. Now I'm going to do one more integration, which is just one fraction. That's x squared plus 3. Now I just assume I know what is my numbers on the top. So I assume b is 3 and c is 0. So I'm just going to assume that. Okay, now let's continue. Right. So right here, I'm going to follow the u prime method because I say my degree is 1 for the whole denominator. Right, so I use u to be x squared plus 3. I take a derivative of that. I'm going to get a 2x. Okay, I need a 2x. I do have x on the top. I'm missing only the 2. So now I'm going to put the 3 in front, do a half. Now I create a 2x. Right, I just move the 3, put in front, give us half, and make a 2. Now I have 2x to prepare. Now it's very clear we can solve this because we have our u prime. So that's going to be ln. Absolute value, even you know this is going to be positive anyway because x squared plus 3 is going to be positive. I just do it. I just gave absolute value because right now you have to remember you have to give absolute value. Any questions so far? now you have to think about, for taking integration of the first fraction, it's very hard. But if I rewrite it as partial fractions, we are able to solve it. That's the reason partial fraction is so important for us. It's going to help us to solve some of the problems we have. If we are able to do the factoring for the denominator, we may able to solve it. That's the reason we are dealing with partial fractions right now, to do some of the problems for our rational functions. All right, we're going to do one more example. Let's go back to the easy one we had before. Then we're going to go over how to solve the partial fractions, which you learned in pre-calculus. Okay, so now let's starting with one problem. 3x squared minus 1 dx. So first we're going to check the degree is 1 for the denominator. Now this is rational function form. So first thing I'm going to do is, can I do factoring for my denominator? Yes. Because my factoring for the denominator is x plus 1, x minus 1. 3 doesn't really matter, as you know. All right, so we can put a 3 in front later on. So now we are trying to rewrite this into partial fraction form. So we just did that before. I'm just going to rewrite. So now that's going to be x plus 1, x minus 1. Let's forget about the 3. So I'm going to put 1 right here. Now this is going to be equals to x plus 1. It's a linear function, so the numerator is going to be a as a constant, b the second constant, x minus 1. Whenever I get a and b, the problem is going to be solved, because I have no trouble to do integration of a constant number divided by x plus 1, because u prime is 1. And I have no problem to take an integration of b over x plus 1, because the derivative of x minus 1 is still going to be 1. So whenever we find a, b, the problem basically is solved. So now let's find a and b. There are two different ways to find a and b. I'm going to teach you. First way is we do a sign a value. Right. Let's do that. Method 1. So what we're going to do is we combine these two fractions. So combine the two fractions means we are adding these two fractions. So in order to add these two fractions, right, we have to have the same denominator, which will be x plus 1, x minus 1. So for the first fraction, we are missing x minus 1. So we're going to times x minus 1. For the second fraction, we are missing the x plus 1. So I'm going to times x plus 1. Now on the top, the first one will be a times x plus 1. X minus 1, plus the second fraction, the numerator will be x plus 1. And this new fraction we make, two fractions add up, should be equivalent to the original fraction, which we have 1 over x plus 1, x minus 1. In order to get a and b, the numerator here should be equals to 1. That's the equation we need to solve it. Alright, so it's very clear. We have the same denominator, so the top has to be the same in order to give the same fractions. So x minus 1 plus b x plus 1 should be equals to 1. But I have one equation, one variable. We have three variables, a, b, and x. Right? It's going to be very hard to solve. So the idea is we assign a value for the x to see if I can eliminate two variables. Right? If I assign the best number to assign, maybe let's see, I assign x equals to 1. Why are we doing that? Because I can make this to be a 0. Now I eliminate this whole thing. Because when x equals to 1, 1 minus 1 is 0, a times 0 is 0. So when x equals to 1, we're gonna have b only. X is 1, so it's 1 plus 1 equals to 1. Now we can solve for b. b will be b times 2 equals to 1, b equals to a half. We're gonna apply the same way to do the second part, x plus 1. So if that part is 0, then I can get a. So we're gonna do x equals to -1. So when x equals to -1, we're gonna have a -1 equals to 1, because b right now is times -1 plus 1, 0. So now I get an a, which is -1/2. Since our topic is integration, so we're gonna focus on integration. Right, so the partial fraction part, we're gonna do more examples in the future. Now let's back to our integration. So since we rewrite and we get a and b, now the original problem, we can rewrite it. So origin problem is 3x squared minus 1 dx. Now we use partial fractions. We rewrite this problem to be 3, take an integration of 1 over x squared minus 1 dx. So this will be the partial fraction we solved, which is 3. Since a is 1, so it's 1 over, a is a -1/2. That's -1/2 over x plus 1 dx. That's going to be two fractions plus integration of +1/2 over x minus 1 dx. Of course, the fractions on the top is bad, so I'm going to put in this whole thing in front. Right, so let's multiply the 3, so that's going to be -3 over 2, take integration of 1 over x plus 1 dx. Put 1/2 in front, that's going to be a half, 1 over x minus 1 dx. As this is a very special case we have, this is also a very special case. Because when I take a u prime, and this is going to be give us 1, so 1 we don't have to worry, so we can give the final answer right away. That's going to be -3 over 2 ln x plus 1 plus half ln x minus 1 plus c. So far we have one example using partial fractions to solve the problem. We're gonna do one more example so everybody get used to how to solve this problem, right? So first thing I'm gonna do is check what type of problem I should deal with. So first I think about this is a problem for the degree 1. So now this is rational function form. Now I have to think about if it's possible for me to do the factoring, right? This is second step. I'm trying to do the factoring here, but since we are dealing with partial fractions, so I'm thinking about factoring. But the first thing we should do is check the degree. So what I mean by check the degree is what's the degree for my numerator, what's the degree for my denominator. For the on the top, the degree for the function we have is 1. For the bottom we have, the degree for the function is 2. The highest is 2. The highest on the top is 1. This is partial fraction problem if we are able to do factoring. Right? How about we have the same degree? We're gonna do it later. How about the top degree is higher? We're gonna do that later. So now we are dealing with is the top degree is lower than my denominator, and now I'm trying to do the factoring to see if I can do factoring for my denominator. So x squared minus x minus 6, that's gonna be x minus 3 times x plus 2. The top will be 2x. I don't care about the top as I mentioned. Right, no matter it's the 2 I have or 2x I have, unless it's 2x squared. Now they have the same degree. I have to pay attention for that. Right now everything is fine. We are gonna solve this by using partial fractions. So first we're gonna set up 2 fractions for this. Right, I'm gonna rewrite. That's gonna be 2x x minus 3 x plus 2. That's going to be the same as x minus 3. We don't care about this x right here because we only care about when I do partial fractions. I have to follow. If it's a linear function, I have to give a. If it's x squared functions, I have to give ax plus b, right? That's it. Now we have 2 fractions set up. I see somebody mentioned about, right, there's a typo right here, is we have, the final answer should be 3 times a half. Now let's continue for the fractions right here. So now we have 2. Now, so first part will be a times x plus 2 because our denominator, common denominator, will be x minus 3 x plus 2 plus b x minus 3, and the whole thing add up should be equals to 2x. We follow the same formula to see I can plug in value for x to help me to solve it. Now, can somebody tell me what's the number I should use to solve this? After you figure out what number to use, I want somebody tell me what A is, what B is. I will give you a few minutes to try to solve this by yourself. Since I say there's some different answers, we're gonna do it right now. Right, let's say the first number we're gonna put will be a -2 to make the first term to be 0. The second part, we're gonna have x equals to 3. So to have 3 minus 3 to be 0. Right, so x will be -2, and 1 will be x equals to a 3. So let's do -2, -2, that's going to be b, -2, -3 equals to -4, right, because -2 times 2 is -4. So here we have b times -5 equals to -4. So b is -4 over -5, 4 over 5. For x equals to 3, so the second term will be 0. So that's going to be a times 3 plus 2 equals to 2 times the 3. So that's 5a equals to 6. So a is 6 over 5. Now we get A and B. Once we get A and B, the whole problem will be changed to a new form, has 2 fractions add up. Right, so let's go over our whole steps. At the beginning we have 2x, x squared minus x minus 6 dx. Now we have our steps to try u prime to check the power and check to see which format we should consider. So then we know, okay, this problem should be a partial fraction problem, right? So then we rewrite this into a over x minus 3 dx plus b over x plus 2 dx. It's better to have AB in front, right, to help us to solve. So I'm going to put AB in front. A will be 6 over 5 1 over x minus 3 dx plus b, which is 4 over 5. Now it's a very special case. Again, x minus 3 u prime is 1, x plus 2 u prime is 1. So now we are done. This is 6 over 5 ln x minus 3 plus over 5 ln x plus 2 plus c. For myself, I did u prime checking. I don't know if you did that. If let's go back to the original function we have right here. Right, if do the first u prime checking, so my u is x squared minus x minus 6. So my u prime is 2x minus 1. Do I have it? I don't have it. Now the question is, can we make it? Should we make it? We already solved this by partial fractions. So there's no use to do this, to make 2x minus 1, to use u prime method. All right, let's see, how can I make 2x minus 1 if we have something we could do for it. Let's have a new problem right here. X over x plus 1 dx. So I first check the degree is 1, so I'm consider this is rational functions. Now I check my u prime method. U prime x plus 1 is 1. No good, because I have x on the top. We cannot do it. Now is this partial fractions? It's not partial fraction because I have x plus 1. It's only one term. Partial fractions has to have factoring, right? There's no factoring. So now I check the degree. Degree for the function is 1 for the x right here. Degree of here is 1. So whenever we have the same degree, or the top degree is higher than denominator, we will do long division. So long division, which you learned before, right? But this is a very special case because I'm talking about how to make the minus 1 right here. So if you have trouble do long division, there's a special method we can apply is, let's make x plus 1. So what I just did is add 1 for my x, so I make x plus 1. Since I add 1, change the function, so we have to subtract 1. So I didn't do anything. I just adding 1, subtract 1. However, I created something special. What I created is, I have my first part, which is x plus 1, the same as my denominator. Then I have remaining to be a second fraction. Now the first part is 1 dx. The second part is just our rational function form for basic ln problem. So now we can solve this. 1, take the integration of 1, that's going to be x. Take the integration, this is a special case because u prime is 1, so that's going to be right away x plus 1 plus c. As I just said, this looks like a long division problem too. right? How can I do long division for this? I want you to try long division, or you still remember long division, right? Long division is we do a divide. So what we divide is the top is x. We divide it by x plus 1. For long division, we have to have all the terms. The terms are from the highest degree to the lowest degree and a constant. So here I don't have constant for my inside. You can make it. So I just make a 0 right here to prepare for the division. In order to make a division, we have to have the same x. So here it is the same, so it's going to be 1. So 1 times x is x. 1 times 1 is 1. So it depends on how you learned before. Somebody changes sign to adding, or you do subtraction. So our class, when I show you, I'm gonna do the subtract. Right now I do the subtraction right here. So that's subtraction sign. Tell you that we do a subtraction. So x minus x is 0. 0 minus 1 is -1. Remember how you write the long division answers. Long division answers you should give is 1 plus the remainder right here over our denominator we had before, x plus 1. That's exactly what we have when we do the special method right here. The reason we're doing adding 1 minus 1 because I want to go over completing square in the future. So I use the special way to show you. But long division, that's going to be our topic for next Friday. I'm going to also post some problems for partial fractions you're going to go over. And there's some sections come out for partial fractions if you forget. So you can join our 206 review for partial fractions. Now anyone has questions? I want to everyone tell me how you like this class in this way, because for our online class we do not have to do the live teaching, but I think it's going to be good for us to have the class online so I can help everyone. If you like this way, let me know, give me the feedback so we can prepare for our next class next Friday, the same time. Then I'm gonna meet everyone. So I have a second class coming at 1 o'clock. We're gonna have more things, go over the rational function integrations. So second class it's faster than our class so far because we have hybrid part, right? So you can still join our second class if you have time today. I hope everybody have a good time. Then I'm gonna post the homework. Our exam will be take home. I'm gonna post it. I let you know how we're gonna do that later on. All right. So I see you next Friday, and enjoying your weekend.